Escomatic coil-fed automatic lathe, model D2 and D4. Setup operator training system. Lesson number 6, setting up cams. During setup of the model D2 and D4 Escomatics, it will be necessary to change and adjust cams for a particular job. There are two camshafts on the model D2 Escomatic, the main camshaft and the stock straightener camshaft. The stock straightener camshaft is driven by the main camshaft from this single sprocket wheel and chain mounted on the operator's side of the main camshaft. Below the stock straightener is a double sprocket wheel mounted on the stock straightener camshaft. The straightener camshaft is driven by this sprocket wheel and chain. This is a disc-type tool cam used on the model D2 and D4 machines. Each tool cam is numbered with its tool position in which it is to be used and its part number. This cam is for tool position number 2 and this is the part number. One full rotation of the cam and camshaft is 360 degrees. This zero mark indicates the zero reference mark of the cam. The zero mark is used as a reference in setup of the machine camshaft and cam. This is a layout of tool cam number 2. Rotation of the cam would be clockwise. This portion of the tool cam is called a rise in the cam. Notice that the radius from this point to this point on the tool cam increases. The point at which the tool cam reaches its largest radius is called the high point of the cam. This portion of the tool cam is called a fall in the cam. As the cam rotates clockwise, the radius of the cam decreases during each fall portion of the cam. The smallest radius of the tool cam is called the low point of the cam. Notice on this portion of the tool cam that the radius stays the same. There is no rise or fall in the tool cam. This is called a dwell in the cam. The tool will cut at the same depth for the length of the dwell. Depending upon the shape of the part to be cut, there may be a number of rises, falls, and dwells in a tool cam. During the setup of the D2 and D4 machines, it will be necessary to change tool cams to fit the particular job. Make sure the tooling from the previous job has been removed. Loosen and remove the thumb screw holding the chain and cam cover. Remove the chain and cam cover. Before changing the tool cams, make sure the main camshaft is at its zero point. This is the chain tension adjuster. The tension adjuster is loosened to remove the tool cams. With a 5 mm Allen wrench, loosen this lock screw that holds the chain tension adjuster in place. Next, with a wrench, loosen the small lock nut on the outside of the main camshaft. Remove the nut and sprocket wheel and chain. Next, remove the cams from the previous job. Wipe the cam area clean. Check the followers for burrs or chips. If the followers are damaged or worn, the followers must be replaced. Now mount your new cams with the zero reference marks facing out. Place tool cam number 1 onto the camshaft and slide it back into position. Align the zero mark of cam number 1 under its cam follower. Next, place the spacer onto the camshaft. Next, place cam number 2 onto the camshaft and align its zero mark under its cam follower. In some cases, only one tool cam will be used. When this occurs, the cam should be mounted in the position for cam number 1. Appropriate spacers are then used to take the position of cam number 2. Make sure that the cam's zero marks are still under their followers. Replace the sprocket wheel and chain and nut. Tighten the smaller nut at this time to hold the cams securely. At the same time that you change the tool cams, the stock straightener cam shaft ratio should be checked. Since the single sprocket wheel and chain are removed to replace the tool cams, it will be easy to also change to a different single sprocket wheel if necessary. The stock straightener cam shaft can run at two different ratios, 1-to-1 ratio and a 2-to-1 ratio. The 1-to-1 ratio is most commonly used. This means a stock straightener camshaft will make one revolution for each revolution of the main camshaft. A 2-to-1 ratio means that the main camshaft will make 2 revolutions for each revolution of the stock straightener camshaft. Check your layout sheet for the production rate. For production rates of 1 to 32, a 1-to-1 ratio should be used. Production rates of 35.5 to 63 parts per minute use a 2-to-1 ratio. If the stock straightener ratio must be changed from 1-to-1 to 2-to-1, the sprocket wheel mounted on the main camshaft must be replaced with this smaller sprocket wheel. The chain position must also be changed on this double sprocket wheel under the stock straightener. To change the stock straightener camshaft ratio from 1-to-1 to 2-to-1, loosen the large lock nut and the small lock nut on the end of the main camshaft. Remove both the large and small lock nuts from the main camshaft. Next, remove the keyed spacer. Pull the 1-to-1 ratio sprocket wheel off the shaft. Remove the threaded collar from the hole in the sprocket wheel. The threaded collar is used to hold the sprocket wheel. The keyway on the outside is for the keyed spacer. The key of the inside mates with the keyway on the main camshaft. Wipe the threaded collar off and install it onto the main camshaft. Align the key and keyway. Install the smaller 2-to-1 ratio sprocket wheel onto the shaft. Align the key of the spacer and install the spacer onto the shaft. Replace the large lock nut on the shaft. Place the chain on the sprocket wheel. Replace the small lock nut. Tighten down the small lock nut. The chain position must also be changed on this double sprocket wheel under the stock straightener. The chain must be placed on the larger of the 2 sprocket wheels. Loosen the set screw that holds the double sprocket wheel in place. Slide the double sprocket wheel to the right. This aligns the front and back sprocket wheels. Then lock down the set screw. Now move the chain to the large sprocket wheel. You must now bring the chain tension adjuster into position. Lock the tension adjuster in place with the set screw. Now lock down the large lock nut on the main camshaft. This will lock the sprocket wheel to the main camshaft. To change from a 2-to-1 stock straightener ratio to a 1-to-1 ratio, the procedure is the same. These are feed cams used on a D2 or D4 schematic. The cams are slotted to slide on to the main camshaft. Both feed cams are marked with a 0 point as a reference. This mark will be used to time the feed cam to the 0 point of the main camshaft. The feed cam on the left is the second feed cam. The second feed cam may be mounted in place of a return cam on some jobs. The cam on the right is the first feed cam. This is a layout of a feed cam. Rotation of the cam is clockwise. Notice this portion of the feed cam. This is a rise in the feed cam. The radius in the feed cam has increased. This increase or rise in the feed cam will cause stock to be fed out by the feed rolls. On this portion of the feed cam there is a dwell. The radius of the feed cam stays the same during the dwell. No stock will be fed out for the length of the dwell in the feed cam. The feed cam will continue to increase in radius and feed stock until it reaches its highest point. After the high point of the feed cam, the cam radius will decrease. Before this decrease in radius, the cam follower will begin to ride on the return cam. During this time, the feed attachment will be returned to its starting point. The feed attachment will then be ready to feed material for the next piece. Because of the slot in the feed cam and the amount of time allotted for the return of the feed attachment, another cam called a return cam is mounted next to the feed cam. This is a 65-degree return cam with an adjustable segment. A slot is cut into this cam for mounting to the main camshaft. The cam followers of the feed attachment will begin to ride on the return cam at the high point of the feed cam. This is just before the return portion of the feed cam. There should be no rise or fall during this transition. This is the return portion of the return cam. The purpose of the return portion of the cam is to control the return of the feed attachment. The return should be smooth with no drop or bounce action given to the feed attachment. Depending upon the part being produced, the return time for the feed attachment may be varied. This is the adjustable return segment. By loosening this bolt, the segment may be adjusted for proper duration of the return. When the adjustable segment is removed, the return time for the cam is shortened to 40 degrees. This may allow 25 degrees more time to the feed portion of the cycle. The return cams just shown can be used with a 2-to-1 or a 3-to-1 ratio feed levers. The return cams shown have 2 holes bored into the side of the cams. The holes are used to mate with a pin in the clutch cam segment. The hole on the left is used for the feed ratio of 2-to-1. The hole to the right is used for a 3-to-1 feed ratio. This is another 65-degree return cam. It has no adjustable return segment. The return time is built into the cam. There is only one hole bored into the cam. This return cam is used with a 1-to-1 feed ratio. This cam is a 130-degree return cam. There is only one hole bored in this return cam. This 130-degree return cam is used with a 1-to-1 ratio feed attachment. This is a clutch cam segment. The clutch cam segments have a pin to mate with a hole in the return cam or second feed cam. The purpose of the clutch cam segments is to disengage the friction clutch driving the feed rolls. When the pin in the clutch cam is mated to the proper hole in the return cam, the timing is set between the two cams. When the feed cam is adjusted with the return cam, it will also then be timed with the disengaging of the friction clutch. Clutch cam segments must match the return cam return time. A 65-degree return cam must be used with a 65-degree clutch cam segment. A 40-degree return cam must be used with a 40-degree clutch cam segment. A 130-degree return cam must be used with a 130-degree clutch cam segment. This will assure that there will be no stock movement during the return of the feed lever. To replace the feed cam, return cam, and clutch cam segment, make sure that the main camshaft is at its zero reference point and the tool cam's zero marks are set under their cam followers. Loosen this lock nut on the main camshaft. Slide the lock nut to the left. To remove the cams from the previous job, slide the cams to the left to this flat spot on the main camshaft and pull them off. You may have to rotate the cams by hand to get them in position to be removed. Check your layout sheet and the feed cams to determine the feed ratio for the new job. You will use this information to determine what feed attachment to mount. First, install the proper clutch cam segment. Make sure the pin on the clutch cam faces the operator control side of the machine. Slide the cam onto the flat spot on the cam shaft. Work the cam to the right. Next, install the proper return cam onto the shaft. Align and mate the correct feed ratio hole on the return cam with the pin on the clutch cam. Next, slide the spacer to the right against the return cam. Now install the feed cam onto the flat spot of the cam shaft and slide it to the right. The zero reference mark on the feed cam should face the operator control side of the machine. The 0 degree mark should be at the top of the cam to align under the cam follower of the feed attachment when installed. Slide the spacer to the right. Snug down the lock nut, but do not fully tighten it at this time. Move the return cam to its approximate position to bridge the return portion of the feed cam. Notice this portion of the return cam. At this point on the return cam, the feed attachment cam follower will contact the return cam. Feed is disengaged at this point of the cam. Snug the nut down to hold the cams in position. In some cases, a second feed cam will be used in place of a return cam. For these jobs, the second feed cam, in addition to feeding stock, will control the return of the feed attachment. Mount the second feed cam with its 0 reference mark facing the operator control side of the machine. When installing the second feed cam, align and mate the hole in the cam with the clutch cam pin. Timing between feed cams 1 and 2 is set by aligning both 0 marks together under the cam followers. Slide the nut over and just snug it down. Final timing of the cams will be set in later lessons after mounting of the proper feed attachment. This is a changeable counter-collet cam segment used on Model D2 schematics. The purpose of the counter-collet cam is to open the counter-collet. The counter-collet is closed by spring pressure at the collet assembly. A standard segment is used when gripping a part on the largest diameter of the part. When a part must be gripped on a smaller diameter rather than a larger diameter, a special cam segment must be used. This is the standard counter-collet segment. The counter-collet cam is marked with a 0 reference mark. The mark is used to align the cam to the 0 position of the main camshaft. The counter-collet cam is mounted to this counter-collet cam mounting plate, located here on the main camshaft of the Model D2. Before installing the counter-collet cam, make sure the main camshaft is at its 0 point and the tool cam 0 marks are under their cam followers. On the counter-collet mounting plate, there are 4 possible mounting positions for the counter-collet cam. Install the counter-collet cam to the mounting hole closest to its cam follower. Slide this lip on the counter-collet cam into this groove on the mounting plate. Install the holding bolt and tighten the cam into position. Loosen this lock nut located here behind the counter-collet mounting plate. You can now rotate the mounting plate until the countercollet cam 0 mark is under its cam follower. Retighten the lock nut. The overbend straightener jaw cam, straightener slide return cam, and stock clamping jaw cam must be changed to match the return time of the feet attachment and clutch cam used. On the Model D4 S-Schematic, there are 3 camshafts: the main camshaft, straightener camshaft, and drill turret camshaft. Operation of the main and straightener camshafts and cams on the D2 and D4 are identical. Because the countercollet of the D4 model is mounted in the front of the drill turret, its control cam is not mounted on the main camshaft. On the main camshaft, in the location where the countercollet cam for the Model D2 is located, is a chain and sprocket wheel. The purpose of the chain and sprocket wheel is to provide drive to the drill turret camshaft. These are the disc type of drill cams and the countercollet cam mounted on the drill turret camshaft. Each of the cams are marked with a 0 reference mark, cam part number, and description, whether it is a drill cam or countercollet cam. The countercollet cam is usually the larger of the 3 cams and is usually mounted closest to the machine frame. Before mounting the drill and countercollet cams, make sure that the main camshaft is set to its 0 reference position. 0 of the main camshaft will correspond to the 0 of the drill turret camshaft. Wipe down the cams and camshaft before mounting. Install the countercollet cam on the camshaft with its 0 mark facing out. This is tool position number 3. Align the 0 mark under the follower. Install the spacer next. Make sure to align the pin in the spacer to the slot in the camshaft. Next, install the drill cam and align its 0 mark to its cam follower. This is tool position number 4. Install the next spacer and drill cam in the same manner in tool position number 5. Then install the final spacer and lock nut. Tighten the lock nut. Check that all 0 marks still align with their cam followers. This completes your television training tape on setting up cams. You may watch this tape as many times as necessary to fully understand the material. After you have finished, return to the operator's book for your next step.